see what we got. Hope I can do this before going to bed here. Yeah, couldn't finish the last one. Oh, could definitely not even start the last one. Alright, maximize area of square hole in grid medium. You're given two integers n and m and two integer arrays h bars and v bars. Probably horizontal and vertical. Grid has n plus 2 horizontal and m plus 2 vertical bars representing creating 1 by 1 unit cells. Okay, sure. You can move some of the bars in h bars from the horizontal bars, and some of the bars in v bars from vertical bars. Note that bars are fixed and cannot be removed. Note that other bars are fixed and cannot be removed. Return an integer denoting the maximum area of a square-shaped hole in the grid after removing some bars, possibly none. Huh, okay. Return an integer denoting the maximum area. So it really doesn't matter. So in this example, there it could remove the horizontal bar 2, or you could actually move the horizontal bar 3 and the vertical bar 2, and you get a 4 area 2 by 2 in the bottom half. But here, like, you don't really care to figure out which bars you want to remove. You just want to figure out what the hole would be. So it's just a case of identifying what the biggest hole could possibly be, and then like you'll remove some number of bars to get that hole to be there. And the hole is just based on like the difference between the horizontal bars and the distance between vertical bars. Like any possible difference, right? Like you have 1, 2, 3, 4 as your horizontal bars. Wait, what's going on here? H bars is 2, 3. Oh wait, what's going on? Grid has n plus 2 horizontal and m plus 2 vertical bars. Horizontal bars 2, 3. Bars are indexed starting from 1. You can remove some bars in H bars and some bars in V bars. N equals 2 means what? The grid has n plus 2 horizontal bars. Explanation: the left image shows the grid formed by the bars. The horizontal bars are 1, 2, 3, 4. Oh. Is 1 and 4 automatically there? How is 2 and 3 just listed? Why isn't it 1, 2, 3, 4? H bars is 2, and it's 1 and 3. This is 3 bars 2, and it's 1 and 3. The grid has n plus 2 horizontal and n plus 2 vertical bars. Horizontal bars is 2 and 3, vertical bars is 2 and 4. So why is there 3 here? What's going on? Why is there vertical bar 3? One way is removing the horizontal bar at 3 and the vertical bar at 4. integers n and m and two integer arrays h bars and b bars. The grid has n plus 2 horizontal and vertical bars, n plus 2 horizontal and b, and m plus 2 vertical bars, creating 1 by 1 unit cells. The bars are indexed unit starting from 1. You can move some bars in h bars and some bars in b bars. Some h bars and horizontal bars. N is 2. The grid has n plus 2. So if 2 is, so it's a 4 by 3. Sure. So it's a 4 by 5. Sure. Oh, I see. So it starts out with a full grid, and then only these bars can be removed. Oh my god, that took me a long time. Okay, sure. That's a lot harder than my original understanding of it, which makes sense. My original understanding of it would have been very simple. So here you move 2 and you move horizontal bar 3 and vertical bar 4. Sure. Does it make a difference though? So, like, in theory, right? Assuming the h bars is not the actual, yeah, the bars that you remove are not the outside bars, the perimeter bars. It's one of the inside bars. So in theory, any horizontal plus any vertical bar that you remove, just any single one that is inside the perimeter is going to cause you to have a 2 by 2. There's just no way that that's not going to occur. So then if you wanted to actually have something that's bigger than that, then you have to have like a consecutive horizontal bars plus consecutive vertical bars. Like it has to be like a 2 and 3 plus a 2 and 3 or a 3 and 4 in order for it to have a kind of horizontal, or in order for it to have a gap of 3 in one direction and a gap of 3 in the other direction that forms a 3 by 3. So what you're looking for really is the longest consecutive numbers, the longest streak of consecutive numbers in both your horizontal and vertical bars, and then the minimum of the streaks is going to give you one less than the side length of the square that your hole is going to be. I guess if your streak is 2, like it's like a 2, 3, and a 3, 4 here, then that means you can get a 3 by 3, basically a 3 side length. If your streak was like 3, like let's say it was 2, 3, 4, and say like n was 100, m was 100, 2, 3, 4 here, and like 4, 5, 6 here, then it'd be 4 by 4. But if it was like 3 here and 4 here, then the 3 is the limiting factor, and that'd be like a 4 by 4. Okay, so it's just the longest streaks, I guess. I don't think h bars is necessarily sorted, right? So I think first is going to be just to sort h bars and b bars sort as well. I'll say the longest let's say max H streak. I'll say that starts at maybe 1. So how do I go about calculating the longest streak here? It should be pretty simple, right? Okay, so for every, let's say previous is equal to 0, for every H bar in H bars, if this current H bar is greater than the previous by 1, then the current streak is going to increment by 1. I'll say the current streak is currently 0. Else the current streak resets, right? Else streak resets to 1. Because I guess it should always start with 1. So if it's like 2 and then there's 3, then 2 starts at 1, 3 goes to 2. And then I guess I can say if as I increase the streak, or if I break the streak, that's when I check. So here, if I reset the streak, then whatever the current streak is, I'll check to see if it's bigger than the max streak. If the current streak is greater than max H streak, then max H streak is equal to the current streak. And because this is done inside the loop, this if statement, then I do need to actually have the final one after the thing. Because it could technically be that the final streak is the longest streak, and it would never reach this else because it doesn't get broken. Alright, and then same thing for max B streak is equal to 1, previous equals the current streak, which is equal to 0, for every B bar in B bars, if B bar equal to previous plus 1, streak increments, else if the streak is greater than the max B streak is equal to current streak is reset to 1. That's, did I forget to do the 4? And then same thing, if streak greater than max B streak, then max B streak is equal to this current streak. I wonder if I actually, no, that's right. And then return basically the minimum between those two, streak plus 1. So the max H streak, the max B streak plus 1 squared. Alright, I'm pretty sure this works. Anything else I want to tidy this thing up with? Not really. I guess I can make a function out of this, right? Yeah, this is probably just should be function. It's all very, oh my god, it's so similar. Okay, let's do define longest, find max streak, and I'll take in the array, and it'll be a list of integers. It'll return an integer, and then array trace sort, I'll say the max streak is going to be equal to 1, previous streak equals 0. For every value in the array, if that value is equal to the previous plus 1. Don, do I ever change the previous? Wait, how is that even working? Oh boy, it's not going to work correctly there. Why would it be? The answer is all 4. Yeah, this is not working actually. It should change the previous. Yeah. Okay, I'll fix it here. If the value is equal to previous plus 1, streak increments. Else, if the streak is greater than the max streak is equal to streak. Streak resets to 1, and then the value previous is equal to the current value. If the streak is greater than max streak, max streak equals this current streak. Actually, this is probably just the return value. So return the max streak if max streak is greater than the ending streak here, else return streak. Alright, and then I just say side is equal to the minimum of find max streak, passing in h bars, find max streak, passing b bars plus 1, and then return side times side. Okay, let's go ahead and just do another test case because all the test cases were there, returning 4. So I think maybe, let's say 100 by 100, and let's do something simple like 1, 2, say 5, say 10, 11, 12. So that gives you the 3 consecutive, say 2, 5, 6, say 14, 15, 16, 17, so that gives you 4 consecutive, so the answer should be 3, 4 by 4, 4 by 4. So it should be 16. Yeah, so this thing gives you kind of 3 in a row, which gives you 4 gap. 4 in a row gives you 5 gap, so it's 4 gap by 4 gap, which is 16 area. Okay, I think, well, good thing I caught that one error. Okay, this sounds pretty good. Alright, well, that was simple enough once I understood the problem. Summary. In order to create a big square hole, need to remove consecutive h bars and consecutive b bars to form a kind of vertical gap. Right, you have 2 consecutive h bars, let's say at 10 and 11, then you're forming a vertical gap between 9 and 12. For example, remove h10, h11, gap forms from 9 to 12. And similarly, need to remove consecutive b bars to form a horizontal gap. To find the biggest hole, look for the longest kind of vertical and horizontal gaps. The smaller of the two will determine the size of the side length of the square. So our sample 4x5 gap would, since 4 is smaller than 5, would mean that there's a 4x4 square hole at most. Here above creates a simple helper function that takes an array, either h bars or v bars, and returns the longest consecutive streak of values, applies both functions to, applies or calls that function on both arrays, and then determines the size of largest hole based on that. And I mean, it's pretty simple in terms of like how you find longest consecutive array. It's like you sort the array. You start with saying your streak might be 1, you have the previous value. You can also do this with I use a for each loop, but you can use an index loop. For each loop is slightly faster in my experience with Python. Anyways, you go every value in the array, compare it to the previous values. If it's that previous value plus 1, then the streak increments. If it doesn't, then you reset the streak back to like 1. And at the time of resetting, you can compare it to the max streak stored and update if necessary. You could technically check to update the streak each time. It's just a little slower since yeah, it doesn't need to be checked each time in theory. And then once you have the max streak of the vertical or the horizontal verticals, one more of that is going to give you the actual gap length, find the minimum gap length, and then side by side to get the area. Time complexity can be simply O of n. Well, let's see. I don't know. I guess it's in the n and m are the same thing, right? 100 length. So O of n over m, in theory, should be O of minimum or O of maximum between m and n. Something like that. If they were actually of different orders of magnitude. Since each array will need to be iterated over in order to determine the longest streak. And then space complexity, this is just simply O of 1, since no extra space is needed.